It's just the start of week 7, isn't it? Yeah. Yeah. So we're doing okay. Okay. Ready? So last time we looked at the first principles method for calculating the derivative. Yeah? So do you remember, for example, the formula is dy dx equals delta y delta x when you make the delta x go to 0? Yes? Who did I get? Yes. Yes, all in the library, huh? Yes, okay. Where's Ricky and Spiway?
Really at home.
And Spiway?
I don't know.
Okay. Fx plus delta x minus fx all over delta x. Remember this? Derivative. Now, you all remember, I think we did this question.
Yeah.
Do you remember it was quite long?
Yeah.
It's quite difficult. So what we're going to look at first is there a quicker way to calculate this? Okay, so that's what we'll have a look at first. Come on guys, no talking please. We're doing this whole math thing now. Okay, so what we want to do here is, rather than using the formula every time, maybe we can find a quicker way to do it. So what I'm going to do is I'm going to imagine my function is like this. And then all we have to do is just change the n for whatever problem we're doing. So for example, if I had something like this, that's the same as x power minus a half. If I had something like this, of course, that's just x squared. If I had something like 1 over x squared, that's x power minus 2. So you can do a lot with this type of function. So let's use the formula and see what we get. So delta y delta x is f x plus delta x minus fx over delta x. So here that would be x plus delta x power n minus x power n all over delta x. I'll just give you a minute. Okay, so what type of problem is this? We've seen this. What type is it? What's it called? Begins with a B? Yeah. Something theorem. Yes, what theorem? Binomial. So we could use Pascal's triangle, but I shouldn't use Pascal's triangle here. Why not? Why should I not use Pascal's triangle? Yeah, you don't know the n. So we should instead use NCUK. So here we would get NC0 xn plus NC1 xn minus 1 delta x plus NC2 xn minus 2, and then this one here would be delta x. What power? 2. Can you see what's happening? I'm decreasing the x power, and then I'm increasing the delta x power. And here are my c's. Etc., 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 minus xn all over delta x. Okay. Does anybody know what NC0 is? 1. Because if you remember Pascal's triangle, you always start with 1. And then if you think about it, what's the next number in on the triangle? Well, yeah, it depends on the row. But if you just remember the triangle for a moment, it goes like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is power 0, power 1, power 2, power 3, power 4, 1, 5, 10, 10, 5, 1, power 5. So you notice that the first number, 5C0, it's always a 1. And then the second number, for example, 5C1 is a 5. And this here will be 4C1, 3C1, 2C1. So it's not going to be a surprise that here, this is a 1. So, gone. And what would this one here be? N, yeah. So here we get xn plus n xn minus 1 delta x plus nc2 xn minus 2 delta x squared dot 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 minus xn all over delta x. Now what's nice is on the top, this will cancel with this, and there's a delta x in everything. So this delta x cancels this, it also cancels one of the powers here, it'll also cancel the next power. So you'll be left with n x n minus 1 plus nc2 x n minus 2 delta x plus more things with delta x in it. So the last step to get dy dx is you make delta x go to 0. So if delta x is 0, what happens to this piece?
All 0.
Gone. And all these ones here is gone. There's only one piece you're left with. This piece here. Now, for people who have seen this formula before, it's not a surprise. So what I'm saying is, if y equals xn, the first derivative, the slope of the tangent, is equal to nxn minus 1. Some people have seen this result before. Those people who've done calculus. What the heck? So now we don't need the first principles method. If you can write it in the form of x power, then you know what the result should be. So I'll give you an example. Example, if y equals x squared, then the slope of the tangent, that would be, sorry, that's x squared. The rule says you bring the power down in front, and then you take one away from the power. So this would be 2 x power 1. Yeah.
So what's the difference between derivative and differentiation?
Nothing. It's just an English thing.
Why is it just the first method?
Because it's on the exam. So that's why.
Because the previous, like this one was quite different between these two.
True, true. First principles is a difficult method to use. Fortunately, it is quite uncommon for the exam. This is good news for you. Okay, so like for another, can I go down a little bit? So do you remember the example we did last time when we had y equals 1 over root x?
Mhm.
Let's try and use this formula. So I change it into y equals x power a half, minus a half. And the rule is, you bring down the power, and then you reduce the power by 1. So this will become minus 3 over 2. Now we can clean this up a little bit, because this would be minus 1 over 2 x power 3 over 2. Yeah? And then, is this the one I did last time, isn't it? Yeah, it is, yeah. And then this would be minus 1 over 2 square root x cubed, which is, I can see the same answer I got last time. Yeah? This is much quicker this way, isn't it? You just have to change it into this form, x power n. And then once you have it written like this, you can just use this rule. So this is like our first rule we've seen. So just one more really quick. If I have y equals 1 over x, that's the same as x power minus 1. So what's the derivative here? It will be minus 1 x power minus 2. So that's minus 1 over x squared is the answer. So the rule is you bring the power down and you take 1 from the power. Okay. So I'm not going to go through the proof of all the rules, but I'll give them to you now. Okay, so once you're ready, I'll give you a table of all the results, which you get most of them in the formula book. Okay, can I go down to the table? Yep. Dude, get off the phone. Put it in your pocket, it'll make me feel better. Okay, continue. Yep. Right, so let me give you the table of results. So what I'm going to do is, on the, there's a nice colour. On the left, I'll write the function, and on the right, I'll write its derivative. By the way, so far I've used this here to mean derivative, but there is another symbol for derivative which I'll use here just to show you something different. A little dash on the x. Maybe someone has seen it this way before as well, but it means the same thing, it means derivative. So the very first rule we did was x power n, that would be n x power n minus 1. The next rule is something that you might remember from your homework last time. If you did the first question, 1b, if you look at the last page, have a look at 1b. Do you remember what the derivative of 1b was? Was 0. In fact, whenever there's a constant, the derivative will be 0.
It's like x power 0.
Yeah, that's it, x power 0 coming down, yeah. And likewise, if you had something like kx, constant times x, the derivative is just k. But that makes perfect sense, because if you think about it, what's the equation of a line? Y equals mx plus c. What's the slope of this line? M. So if I said we have the line kx, what's the slope of kx? K. If I said kx plus c, do you care about the c? No, it's still just k. So these second and third results make perfect sense. You shouldn't be surprised by it. Yes? Okay, so that's the x's. Now on to something a little bit more difficult. If you had something like sine x, its derivative, does anybody know it? Or you could have a guess at it.
Minus cosine.
Good. All right except for the minus, it's cos x.
So the cosine is minus.
That's it, yes. The cos x is minus sine x. Now, does anyone know what the tan x will be?
It's something.
It is something, alright, that's
I
true.
forget what it's called. I will.
No, that is tan x. Something, theta? Something. No, we're all agreed it's something. Right. Do we know what this something is?
It's not sine or
It's
cosine.
not sine and it's not cos. It's, yeah, we haven't done that name yet, secant, but we call it 1 over cos squared x. Now, some people know the name for that. We will do this in semester 2, but we call that secant x, but that's semester 2. Yeah. Secant squared x. Right, so we have x sine cos tan. Now let's have a look at log x. Log x. Does anybody know the derivative of log x?
1 over.
Go on. 1 over something, yeah.
1 over x.
Yes. Log x, its derivative is 1 over x. And finally, we'll say something like a e b x or something like that. Or, sorry, just we'll say e k x. Does anybody know this one?
Yeah.
Almost. It's k e k x. Now, it is actually interesting to note that if the k was 1, you would have ex and its derivative is ex. So when I first introduced e to you, I said e is a special number. Its value is 2.71828, etc. And the reason it's a special number is for this reason. If you use e power x and e is this number, its derivative would be itself. It doesn't change when you differentiate it. If you had something different, if you had like 3 power x, the derivative is not 3 power x, it's something else. And this we will see in semester 2. But what we're saying right now is, if we have 2.718 power x, its derivative is the same as itself. Okay, so you need this table. Now let me just tell you, for the exam formula book, this is in it, this is in it. These aren't in it, but they should be easy to remember. And this is not in it, but you actually need it for the exam. So this is an important one to remember, because I don't think it's in the book, but I have seen it on the exam. So you might want to pay extra attention to this one, because all of these, they're either easy or they're in the formula book. Okay, so please pay extra attention to this one.
Do we have formula book in the?
You do.
In this semester?
Yes. And of course, if you look here, you can see what value of x you can't use. What can't you use for x here? 0. But of course, that's not surprising, because it can't be 0 here. But what's interesting is you can't use negative here, right? It's not allowed. If you type in log minus 2, you get an error. But what's interesting is you can use negative here. So sometimes, not for semester 1, but sometimes you just need to be very careful about the x values you use. So here we could actually use a negative x, but that seems strange because we can't use a negative x here. So for this, I should really maybe say you want to keep your x positive, even though it looks okay, because we need the x to be positive here. But anyways, that's something for later. Okay, have you got this table? We can do some examples. So the first example, um, find the derivative of this, 2e power 9x. Right, you should be able to use the table directly. What would the answer be here? Yeah, it would be 18e power 9x. What about y equals, let's say, root x? I'll give you 1 minute. Do that one for me now. Yeah, we'll put a couple down. Try these. Okay, so this one here, I should change it into y equals x power a half. So the derivative would be a half x power minus a half. And if you want to simplify it, that's 1 over 2 root x. But you don't need to do that for today. They might ask you to do it in the exam though. Here, this is x power minus 2. So the derivative is minus 2x minus 3, which would be minus 2 over x cubed. And lastly here, the derivative would be, what? Just 3 cos x. Straightforward? Okay, try this for me. Question? Albert, yeah?
The example 3.
1, 2, 3, yeah?
Yx minus over 2.
Y minus 2 here?
Minus.
Minus 3?
Yeah, yeah, yeah.
What you do is you bring the power down and then you minus 1 on the power. Yeah, yeah? Okay. Right, can you try this one? I want the derivative of this. Actually, let's make it a little more tricky. Put a 6 here as well.
Where? What?
So it's 4 log 6x power 5. Okay. Any answers? Yes, what you got, Nemo?
Uh, I don't know. I got the second bit.
You got a final answer?
4 log 30 x to the power 4.
Nope.
No.
Not that. We got one? Yes?
4 over 6x5.
Nope. Not this.
20 over 6x.
No.
100
Nope.
24x to the power minus 5.
Nope. 2 over 15x 4, no.
2 over.
It's great that we have so many different answers. Still waiting for the right answer though. Any other guesses?
2 over 3x so on.
Nope, not this. Okay, so
And D was x.
no. The mistake, I understand the mistake people are making, and I did this on purpose. You need to be very, very careful with the table. Look, you can only use the formula when you have log x. It doesn't work when you have log x of a thing. Alright, it has to be just log x. Just log x. So if you look at this, the first thing I would do is change this into log 6 plus log x5 using my first rule of logs. Then what do you think would be the second thing I do?
Not the 6.
No, with the 5.
5 log x.
5 log x. And then the next thing I would do is change this into 4 log 6 plus 20 log x, or to be extra clear, 20 log x plus 4 log 6. Now the reason I had to do that is to make a log x, because my formula book is only for log x, not log 6x5. Okay, what's the derivative here now? Well, what's the derivative of log x? 1 over x. So this will be 20 over x. And the derivative of this? This piece?
0.
0. It's a constant. There's no x in it. It's a constant. So this is the answer, 20 over x, which I don't think anybody said. Important example. So my point is, when you can simplify, it's usually a good idea to simplify when it's possible. Okay? So for logs, you probably should simplify. So like for example, if I had y equals log 1 over x, what should I do first before I use my derivative formula?
Get this like
I should change it into log,
1 minus log x.
well, x power minus 1, which is now minus log x. Now what's the derivative?
Minus 1 over
Minus 1 over x. You see, you get the idea here? Yeah?
I think there is a method you can. You don't want to go to like kind of.
Don't worry, we will see much more calculus in time. Yeah. Can I go down? The other thing I'd like to point out is that if I have something like this x squared and I write this here, that means the derivative of x squared, which would be 2x. If I wrote this, the derivative, and t is the variable, it's the same thing. So, in a way, you can think of the bottom telling you what the variable is. This is like what the unknown is. The variable. There's only ever, there's a problem if you have this. If these don't match, it's a problem. We won't worry about that until semester 2. Semester 1, they should match up. Another way to write derivative is with the little tick. So if I wrote x squared with a tick, that means its derivative, what's its derivative? 2x. Okay. If I had like the same thing, t squared with a tick, that means 2t. Okay, so just be aware of that. Okay, one more example and then we'll have a look at the assignment. Okay, can I go down? Okay, so tell me this. Sorry, Nina, do you have this? Yeah. Do you think this is the same as this? So like if you have, or maybe I should put it like this actually, dx dy is just 1 over dy dx. What do we think? Is it the same, not the same, might be the same? Don't know, maybe the same?
It's the same. Yeah, it's the same.
Let's have a look with an example, okay? So, for example, if I had 3x plus 4y plus 5 equals 0, and I want dy dx, what should I do first before I can get dy dx?
Got
Well, yeah?
the value of y.
Yeah, I need to get the y first. So if I just rearrange this quickly in my head, I can get y equals minus 3x minus 5 over 4. So what's dy dx here? Minus 3 over 4. So we think maybe dx dy is minus 4 over 3. Maybe it's upside down. Let's see what happens. So if I rearrange this to get x, I would have x equals minus 4y minus 5 over 3. Now if I ask you for dx dy, that's the same as dy dx, except I just swap what the x and the y are doing. So like here, you have y on the left, x on the right, y on the top, x on the bottom. Here you have x on the left, y on the right, x on the top, and y on the bottom. So it actually is the same problem. I just literally swapped the x and the y. So then what would be dx dy here? Minus 4 over 3. So yeah, in fact, if you have dy dx equals 3 over 4, it is correct to say dx dy is minus 4 over 3. That you can flip it like this. And this is just a little trick which we more will use in semester 2, but sometimes in the exam they try to trick you and ask you for dx dy, and this confuses students. Don't panic if they ask you for dx dy. You just can get dy dx and then flip your answer. That's all, okay? A lot of times students forget the flip part at the end. So for example, if I had y equals x squared, what's dx dy? Can anyone do it in their head? What would it be? 1 over 2x. Because dy dx is 2x, so dx dy would be 1 over 2x. You just flip it, okay? So the reason I'm showing you this example is because I want you to be careful in the exam. Don't get confused here. Don't forget to flip it at the end if you need to flip it.
Is this used when you like get you want to differentiate linear or equation that has x, y term
Yeah, that's in
together?
semester 2. This kind of continues in semester 2. It's not quite the same. That's called, do you know the name of it? We'll do it in semester 2. It's called implicit derivatives. Implicit. These are explicit. Yeah. Okay, can I close this? Yeah. So if you want, you can take out the assignment page, and if you wanted to, if you had your laptop and you wanted to take it out, that's fine too, okay?
Can we have the question?
Well, I'm going to go through the assignments now. You have a question? Oh, about this? Yeah. Which question?
No, no.
Oh.
If the
Oh
question
yeah,
was,
yeah. I'll give it to you after I go through the assignments, yeah? Oh well, I'll just give it to you now. Homework. Hey, Albert. Homework. Just do all the questions in number one. In number one. Yeah, I think that's enough. So if you can do two and three are the same thing. If you can do all of number one, that's good. And if you wanted to, you can write the answers on the book because they're really, really short. Yeah. Aren't they? Like I can really do them now. Okay, let's have a look at this assignment.